Thank you all for coming. If you're still walking in, there's plenty of seats over here and spread throughout. We are going to get started. My name is Shyam Pather. With me is the famous Chris Anderson. We work in the data and modeling group at Microsoft, and we are here to talk about the Entity Framework in .NET 4 and beyond. So the Entity Framework, as you know, is part of our data and modeling platform. It's the box circled in the big orange oval thingy over there. As you know, it is the ORM stack from Microsoft. The Entity Framework has been out and in your hands for about a year and a half, close to a year and a half. And in that time, we've heard a ton of feedback from all of you about things you like, things you don't like. A few of you raised a few of those points. And we've done a ton of work in .NET 4 to go address some of the things you asked for. So in trying to plan this talk and think about what we were going to show and not show and how we were going to organize it, we decided to do something really, really simple. This is our agenda for today. How many of the great Entity Framework 4 features can we show you in one session? So this is what we're going to try and do. We're going to try to show you everything we did in .NET 4. We're going to move super, super fast, so don't try to write down the code that we're typing. All of this will be available to you later. There's tons of walkthroughs for the stuff that we show you on our blog and in our MSDN documentation and all that. So just sit there and let it flow over you. So with that, let's get started. So Chris, we're firing up here VS 2010, Beta 2.
Fabulous.
And we're going to get started with a new project. Let's do a new console app. So we're doing a data access talk. So let's start by building a database. And we're going to build a database using a feature that you asked for and we gave you in .NET 4. And that is the model-first capability of the Entity Framework. So in here, we're going to add a new item to this project. We're going to pick an ADO.NET entity data model item template. And we're going to add that to our project. Now, this dialog you guys have probably seen before. When this pops up, you'll be given two options, generate from a database or empty model. How many people have ever picked the empty model option? OK, there's like 4 hands that went up.
And you found it tremendously useful, and it solved your problems, right?
This feature was basically useless prior to .NET 4, but we can show you what you can do with it now. We're going to start with an empty model. We're going to get a design surface that's going to pop up that's going to be an empty canvas. And we can use that to start building the conceptual model for our application just by creating some shapes. So let's add an entity here. What do we want to add, Chris?
What are we doing?
Let's
Classic?
do talks.
Speaker
and
talks.
speakers.
Great. Love it.
So one of the things I want to point out is as he types talk there, notice that we get pluralization on the entity set. That was another feature you guys asked for. It was the ability to reason about that. And some of you who were at the data session earlier today may have seen this, but it's actually kind of smart. So let's try a different name. Sheep pluralizes as sheep. How about goose? And geese, people, person. There you go. So pluralization is in the Entity Framework. .NET. Yes. Hippopotamus.
Oh,
you may have found one. OK. OK, whoever called that out gets a T-shirt later.
It was Dawn. That doesn't count.
OK. Oh, it was Dawn. OK, never mind. No T-shirt. Great. You have to give your T-shirt back. All right. So let's add another one. Let's do speakers. So we have 2 entities. Those entities have IDs. And we can go in and tell the model that those are store-generated IDs, identity columns, essentially. And now let's go in and add some properties. So talks, well, let's start with talks. Talks have titles. Talks also need a when are they happening property, which can be a date time, which we'll make nullable. And we'll go in and then do the same for our speakers. So again, we have an ID. We'll have a name, and we're good to go. So 2 entities. Now let's relate them. So we'll go in and add an association to the model. Here we get to pick the 2 ends and specify that it's a many-to-many relationship. When we do that, we'll get the corresponding navigation properties created for us. And now our model's complete. Of course, we could go do additional stuff with the EDM and put inheritance and complex types and all that. But for this demo, here's our model. So Chris, let's go build the database. So you'll notice here there's a new item that's been added to the right-click menu, generate database from model. So let's do that. We'll get a dialog here asking us which SQL server we want to connect to. So we'll point to the local one. We'll create a demo database, which doesn't exist. So we'll be prompted to create it. And the model designer is going to go and take that model that we built, do the engineering it needs to come up with the DDL script. And you'll see there we're creating the 2 tables, as well as the link table that we use to express that many-to-many relationship. So we'll click Finish. And this SQL script will actually be added to our project. So it's there. We can inspect it. We can send it to the DBA to have them look at it. We can add indexes. We can tweak it, what have you. But here, we're just going to run it to get our database. So we'll point at that SQL server. Go. Now we have a complete database. So Chris, let's go back to our code. Let's insert some data using the entity framework. So let's go in and spin up a context. So we'll say using var context is our new Model 1 container. So this is the way we start any entity framework program, by spinning up a context. Let's create a new instance of talk here. And let's do this talk. So we'll give it a title, EF4. EF4 cool features, great. And a when property of right now. And let's maybe do some speakers. So we'll do a new speaker, set its name property. And notice we don't have to specify IDs because we know those are server generated. We'll do maybe another speaker. There we go. And we'll relate those. So given the talk, we can go to the speakers collection on that talk and add the 2 speakers that we just created. And now we'll attach the talk to the context. So we'll go to the context, talks, and we'll context.talks, add object, and pass in the talk, which will basically inform the context about that whole graph, and then call save changes. So let's do this and run. And we didn't actually print anything, so we don't expect any output there. But now we can open up Quadrant, which you may have seen. It's an awesome database visualization tool. We can point Quadrant at our demo database. And you'll see in here the tables that we created, as well as the actual instance data, including the related talks and speakers references that are all fixed up for us. So model first, built the database, wrote some code, inserted some data. So let's go back to the program now and switch from doing these inserts to doing some queries. So let's do a query with the entity framework using link. So let's for each over, so let's say for each var speaker, or s, in the context.speakers. And let's print the speaker name. And let's print the related talks for that speaker. So Chris is going to for each over these speaker.talks. We're going to output the talk title. Now, for those of you who have used the first version of the EF, anything missing here? Load. What's another way to do it? Include. OK, so first version of the EF, we had explicit loading. You had to tell us when you wanted the related collection to get loaded. You asked for lazy loading, and we gave it to you in .NET 4. So here you can see we didn't have to do that include. We didn't have to do the load. We just touched that navigation property. The query for those related talks got executed, and the data got printed as you would expect. So lazy loading, another feature you asked for. Thank you. So now let's take a closer look at the classes we've been working with. So as you know, when we built the model, we got data classes created for us. Speaker, talk, and the context, and so on. So Chris, what's the line count of this file?
370 lines.
370 lines. Now, that seems like an awful lot of code for a talks and speaker model, don't you think?
No, it seems like exactly the right number.
No, I think it's too much.
OK.
So we got some feedback saying, we sure would like some simpler code. That seems like way too much going on in that file. We just want simple POCO, persistence ignorance classes to work with the same entity framework. So let's go look at how that works in .NET 4. So we'll go to our model, and we'll turn off the default code generation. We'll set the code generation strategy to none. When we do that, that code behind file essentially gets emptied out, and we no longer have those classes. So when we go to our program, you'll see a bunch of red squigglies here for the things that are missing. Now let's see if we can try to recreate those classes with less than 370 lines of code. So we'll go in and type a talk class. Let's type a speaker class. And let's do a Model 1 container class. And the speakers and talks, as you know, have just those simple properties. So we'll use the C# automatic properties feature to define the shape of those classes. And we know these have these 3 properties, as well as the related list of speakers. So we'll add a list of speaker property. And we'll initialize that in the constructor for the talk class. Now notice as we're typing these classes don't have any base class. They don't implement any interface. They don't have any attributes on them. They're just plain old CLR or POCO objects. So we're going to do the same thing for speaker here. We'll go fill out the properties, and we'll fill out the related list of talks. So there'll be a list of talks there, which we'll initialize again in the constructor. So far, I think we're doing pretty well against our 370 lines of code. And now let's go implement the context class. So this one derives from object context, because this is where we're now getting into entity framework code. And we're going to write a constructor here that the default constructor will just call the base class, pass in a named connection string, which was generated for us when we did the database generation. And now we'll go create the properties and the context for the entity sets. So as you know, we have talks and speakers. And if you saw this from the old version of the entity framework, you knew these were object query properties. In the new entity framework 4, we've added an object set, an iObject set classes, or interfaces, that make a context super easy to write. So think of an object set as an object query with methods for create, update, and delete on them. So we can just create those, and we now actually have everything we need to run an entity framework application. So should we compile and run? Oh, look at that. So we got the speakers, the speakers, but we lost the lazy loading. The reason we lost the lazy loading is because we're now into the POCO world, and we don't have that built in. So our navigation properties don't know how to do lazy loading. So let's fix that. We're going to go in and make these virtual. And that gives the framework an opportunity to override those properties with ones that do know how to do lazy loading. And we'll set an option here on the context options. We'll say lazy loading enabled equals true. And let's run the app again. And there you see, we now have lazy loading back. So Chris, what's our line count here?
50. Starting
50?
at line 9.
OK, so 41 lines of code. So we've got almost a 10x improvement there.
I can delete some white space. We can make it smaller.
We can make it even smaller than that. We can get more than 10x improvement. So there you go. So POCO, that's one of the things you asked for, and we gave that to you. So Chris is an awesome code typer and got through that pretty quick.
That's a technical term.
Code typer, yeah, that's a discipline. It's a core competency at Microsoft.
Great.
But as you can see, if this model had any more than our 2 entity types, that would have been a huge pain to type. So another thing you asked for is you said, look, I like that code generation gives me code automatically, but I don't want the 370 lines. So we completely revamped code generation in Entity Framework 4. So going back to this model, we have a new code generation system. You'll see there's an item there called Add Code Generation Item, which we'll click. And we're now given a list of templates that we can use to do code generation from that model. So we're going to pick the POCO code generator. And we're going to name this Model 1, which I think it already is named. Yep.
Conveniently.
It needs to match the name of the EDMX file. And we'll click Add. So this system is based on T4. So T4 is the name of a templating code generation engine, really well integrated with Visual Studio. As you can see, there's 2 TT files that are added to the project when we did that. One that generates the context, another one that generates those types. And Chris, if you would, open up, let's say, speaker. You can see that this class, if we open up, say, the primitive properties there, these are just the dead simple POCO classes, just like the ones that we hand typed before. But they were generated for us. So we can run the app now. And because, again, everything's virtual here, we'll get the lazy loading as well. So now we've got POCO with the benefits of code generation, and it's based on T4. So you have the ability to edit and customize those templates for you. So let's go out of this. Now, you all asked for these features, and one of the reasons you wanted them is for testability reasons. So there's stuff we can do in the framework that makes testability easier, but also a part of testability is about how you write your code. So Chris, let's switch this code. Instead of doing an arbitrary query there, let's write a repository class. Let's show how we do the repository pattern and then how we test it. So we're declaring a repository. And we don't want to tightly bind that repository to the EF object context. So instead, what we'll do is define an interface for our context here, which we know our context has two iObject sets. And again, this becomes easy to do because we have this iObject set interface. We'll define talks and speakers. And we know our context has a save changes method, so we'll declare that. Now, this is obviously something we could edit the T4 template and get that template to generate for us. But for the purpose of the demo, we'll just do it here. So now we'll write the repository in terms of that interface. And because we did it this way, later on we can go substitute that real context with a fake one and unit test our context that way. So here we'll write some access methods in our repository. We'll do find speaker by ID, which will go to the context. We'll call single or default. And we'll pass in a lambda expression that compares the ID of the speaker to the one that was passed in. We'll write another access method, which returns an IEnumerable of speakers. We'll say find all speakers. And from this, we'll just go to the context, hit the speakers, and call toList and make it read-only. All right, so now we have a repository. So let's go in and change our program here to use that repository. So here we spin up a real context. We'll instantiate the repository. We'll set the context property to the context we spun up. And we'll change the code here to, instead of, we have a problem there?
Oh, yes, we have a problem.
OK. Well, we'll deal with that in a second. We'll call find all speakers. And
we have an error. We have an error because Model 1 container, that code-generated thing, doesn't implement our cool little interface we just defined.
you raise a good point. So how do we make it generate that? So it was code generated by the T4 template. And usually, generated code you don't want to edit, because if you edit it later on, it can get overwritten and so on.
Don't do that.
But we don't want to do that. So let's go in and actually edit the T4 template. So if this looks like hieroglyphics to you, fear not. There are plugins for Visual Studio you can get that makes this really nice with syntax highlighting and so on. We just don't have them installed here. But in this template, on the line where we generate the class declaration for the context, we're going to go in and make that implement iModel1 container. Great. And we'll make one other change. The properties on the generated context are of the concrete object set type. We're going to change that to be iObject set. So here's a simple example of how we made the T4 template customize. And you can, of course, implement any other interface you like on that. So with that change, we can now compile, and our app runs. So now we've moved our app to a place where we have great separation of concerns. We've got a repository, and we're writing our logic against that. But what if we want to unit test this? How would we do that? Let's add a new unit test to this project, Chris.
Great. I love unit testing. I like to do it first generally, but that's OK.
That's right. So what we're showing you here, obviously we're doing the test afterwards. If you're into TDD, you could, of course, do this beforehand. So we'll add a test project here. And we'll go add some references to this project. We'll point it at the main program, as well as the entity framework. So we'll add that reference. And do you notice how fast this add reference dialog comes up in VS 2010? That's another pretty awesome feature. Yeah. There you go. Great. So now we've got a test method. So because we wrote our repository in terms of the interface, we can go in and actually write a fake implementation of the context, spin up our repository against that fake, and then write tests against it without ever having to hit a database. So I know somebody at the booth asked me a question about this today, so here you're going to see it in action.
Let me just explain one thing I did really quickly there. We have this great interface, iObject set. It turns out it's very easy to implement. Unfortunately, right now, we don't have the very easy to implement version in the framework. So I wrote the version of object set of T that just implemented on terms of a hash set. So we have a simple thing to do in our unit test. So you can see how we use this when we define our fake repository here.
Yep. So in here, we'll actually write a class called, well, not fake repository. This will be a fake context. And it'll implement our iModel1 container. And we probably need to resolve that namespace. Great. And in here, we'll implement the talks and speakers properties as iObject set. And again, there's probably some namespaces there we need to clear up. Great. So we'll have talks, and we'll have speakers. And we'll have a save changes method. And in the save changes method, because this is a fake, we're going to do something really awesome here. and decide that every call to save returns 1. Of course, you could do something more complicated than that or more sophisticated than that if you wanted to. So now we'll write a helper method here that will create a repository bound to an instance of this fake context. So let's go in. We'll return a new repository. We'll set the context to a new fake context. In here, we'll initialize the speakers property. And we'll create a couple of new, we'll create a hash object set, that's right. And in the hash object set, we will put in a few instances of speaker. So we'll go in, and in this case, because we're just using fakes and we don't have the store-generated behavior of the database, we have to specify the ID properties, and that's fine. So we'll add these two. Great. And we, of course, could do the same thing for talks, but we don't really need to do that here. And in the test method, now let's say we wanted to test that find speaker by ID works as we'd expect. So we can do an assert is not null. We can call create repository. We can invoke our method. And we expect for speaker 1 that we get back an object, so it's not null. And we can test that passing in ID 3 will give us a null back. And with that, we should be able to run our test. Now, this test has the advantage of being able to test all of your repository logic without a database being involved, without being dependent on the particular data that is in that database. So this should be really nice. And you can do this now with the Entity Framework really easily because of this iObjectSet interface that we've added to the product. So testability. Great. Another thing you guys asked for is the ability to customize parts of the framework's behavior itself. And in particular, the one area that you asked for was to customize the save changes operation. So we've made the save changes method virtual in .NET 4. So here, Chris is going to do a partial class. So the generated context is a partial class. And here, we'll override the save changes method. And in here, we have access to the whole object state manager where we've been tracking changes. And we can choose to do business logic, validate what's going on here, and so on. In this case, we'll just go and get the object state entries for the entities that are added. We'll count them, and we'll decide that if there's more than one, we're going to throw because we don't ever want to add more than one thing at a time. Kind of a ridiculous example, but you can see in here, you can throw in whatever validation logic you want. You can make this operation fail. You can even completely replace the base save changes operation. But in here, if that check passes, we'll just call the base. And we can exercise this by going in and adding a couple of talks. Let's do more than one. And when we do that, you'll see that the validation logic there fails. So we got a couple of really interesting talks with some awesome titles there. They're really unique titles.
They are. They are distinct talks.
Yeah. And you'll see what happens there. We hit our validation exception. Great. So you can now completely replace save changes by overriding it yourself. Much more flexible customization. That was another specific thing that you guys asked for and we gave you in .NET 4. All right, so we just saw that object state manager there where we did the get object state entries. And that works great for tracking changes to objects when those objects are connected to a context. But we know you have cases where you query for objects and then you ship those objects off either to another tier or another app or another place where you don't have the entity framework or that object context around. And you want to kind of make changes offline, bring those changes back to the entity framework, and get the object state manager to know about them so that you can persist them. So that was super, super hard to do in Entity Framework 3.5. We've made that a lot easier in this version. And we're going to show you a silly little demo app that illustrates how easy this is. So this is an app called disconnected operation. We'll run disconnected operation, and we'll pass in an argument called query, which is just a command that tells the program to go query our database, the same database we created before, by the way, and retrieve talk with ID number 1, and write it out to this file called changelog.txt, which really just contains an XML representation of the talk. It's got the related speakers on that talk, as well as some metadata about is the talk modified, does it have added or modified speakers since it was retrieved from the database. All right, so now we queried from the database and wrote to this file. We're going to run a couple more commands that are not going to really touch the database at all. All they're going to do is make modifications in this file. So let's run a add speaker name equals Donbox. Great. So we've just added Don. And if we type the changelog file, you can see that Don has been added inline into the graph, and he's also been added in the added speakers list. So let's do a modify. Let's change the title of this talk. So this is a silly app that we built that takes these command line arguments and does these things, but we'll make this talk be something that I can't read. But if we type the changelog file now, you'll notice that in that XML, we've done that modification.
So really,
right
this is like doing all of those Outlook operations without syncing back to the backend.
Exactly. They're
So
just
we haven't
operating
modified,
against
in
this.
fact, if we go to, we can actually see that the database still looks the same if we refresh Quadrant. So it's all the same content still up there. We still only have the one speaker.
Great.
So
now let's run another command. There's a submit command here. Now submit is going to take what's in this XML file, spin up a new object context, attach the changed graph, mark the states of things correctly so that the object state manager knows what we did, that we did a modify, we did an add, and so on, and submits it back to the database. And there you can see those changes have been persisted. So we showed you that it was possible through that app. Let's actually take a look at the code that made that possible. And if you've ever had to write this kind of thing with EF35, you'll notice that this becomes simpler. So the heart of this is this changelog class. So this is just a simple poor man's change tracker that I implemented. And it has a talk graph, a Boolean saying whether that's been modified, and a list of added and removed speakers, or added and modified speakers. So let's go down to the submit method, which is where the
magic
happens.
Yeah.
So what we do is we call deserialized changelog to actually take that XML and create an instance of that class I just showed you. Then we spin up a new object context. And of course, this one is a different object context than the one we use to query it, right? Because this is a different invocation of the app. So we attach the talk. We check if the changelog said the talk was modified. And if it is, we call this new API, change object state. And that just tells the state manager, look, this thing's modified. Go mark it as such. We didn't have to touch any properties or anything. We just explicitly call this method. Then we go in and we look at each of the speakers in the graph. If they appear in the added list, we mark that relationship as added. If they appear in the modified list, we mark it as modified. And then we call save changes. So these APIs, change object state, change relationship state, did not exist in the previous version of the EF. And doing the equivalent things was super hard. You had to do graph shredding and all that. You told us you wanted this to be simpler. We've gone and made it simpler for you. So let's. Great.
I don't think they actually buy it. Because while you said, oh, we made it simpler, this so far doesn't look very simple to me.
This isn't simple enough?
No,
there could be a simpler way to do this.
I think we should try. Well, yes, I believe.
OK, let's open up another project we have here.
Great.
Which is essentially the same program. And we've built it a slightly different way. So if you'd go to the model here, Chris. What we did here, so I showed you before that you can do different types of code generation based on T4. So we are using this template here called the self-tracking entities template. And this is available today in the feature CTP of Entity Framework and will be in the box in .NET 4 by the time it ships. And we previously added it to the project, so our context and types there are instances of those self-tracking entities. And now we can write the same program in a much simpler way. So we no longer need that talk changelog class, because these self-tracking entities that were generated have all the machinery in them to already track changes and changes to the graph and so on. Our submit method here becomes just deserializing a talk instance, spinning up a context, calling apply changes, and calling save changes. Now, one thing I need to point out here is we didn't do it, but of course in these scenarios you want to do validation to make sure that the thing you just deserialized isn't nonsense, right? So you would not do what I just did here, but this is where it would go. Don't forget this, especially if you're receiving the thing that you're applying changes to from the internet. But this, I think, is about as simple as it can get. Yes?
Yeah. Great.
Awesome. OK, so we've spent a lot of time talking about improvements to the objects and the way you work with them. Let's think about the way that the Entity Framework works with SQL.
Wait, so there's a database behind all this?
There's a database behind all this. So one of the other pieces of feedback you gave us about the first version of the EF was sometimes when you write a link query, the SQL you got on the back end was less than desirable. Sometimes it was just plain ugly, and you didn't like reading it. You didn't like that SQL Server couldn't optimize it. So we've made some improvements to that. So here we're going to look at 2 examples. So Chris, what's going on here?
So here we have a simple query. We're doing a starts with. We're doing skipping some items, selecting some, but relatively simple query in terms of what it's returning. We'll take a look at that. And the way this little program works, the way the demo works, is it's going to dump the SQL that's going to be generated, and then it dumps the output of it. So we'll see this run. And then we have another query here where we do a really simple query where we just simply go through the categories and select out the count of products associated with each category.
Great.
I'm going to do here is I'm using the multi-targeting feature of Visual Studio 2010. And so I'm actually going to tell this, please run against .NET 3.5, even though we're in Dev 10.
So we're running against the old version of the entity framework, the one that you have today here. So if you look at this, got some generated SQL there.
This is awesome SQL. I've heard that using char index of is great for database performance.
Yes. That
Indexes
totally just
run
skips over
fabulous.
all those indexes because you didn't want those anyway.
And we really wanted every column selected individually.
And this is really
Beautiful.
readable, makes you feel like an expert if you can deal with this.
Yeah.
So this was just awesome.
Yeah,
And
this is like writing inline assembly in your Azure thing.
Exactly,
It's really kind of
yeah.
showing that great, I know what I'm doing thing.
Yeah.
So let's make the monstrous set of changes needed to get these improvements. We'll
Okay.
just simply say, please target .NET 4.0.
So we just changed the target that we're compiling against. We did not change the code at all. We'll run again, and look at this now. So now, that thing that was doing the crazy char index is using a like, which can, of course, take advantage of indexes and so on. And the query is so much more readable. So you can show this to your DBA without being embarrassed, without being ashamed of your application. Similarly with the other one there. So these are just 2 little examples. There's a ton of these. There's a whole document on things that we've improved that's on the team blog that you can take advantage of right now. And notice we didn't have to make any changes to the app. So you can take your existing app, compile against .NET 4, and you are in business with Better SQL. So Better SQL generated from link queries, goodness. But we know there's times where no matter how good the ORM SQL generation is, you just want a pipe to the database. You just want to be able to write your own SQL query, no matter what's in your model, and have that executed. So let's look at how we can do that. So here, Chris is going to write a SQL query. And let's do something that has nothing to do with our model. So what do you want to write here, Chris?
Oh, let's go get, I love the sysobjects table. That's my favorite.
Great.
Which,
So-
everyone puts in their model every time they go to build something, right?
So you told us that you wanted an easier way to just execute SQL when you're in your program. You didn't want to fall off a cliff right when you get to where the ORM can't do what you wanted. So we've added that. So here's a SQL. And let's define a class that matches the result shape of this. And that way, we'll actually be able to write strongly typed code to go over those results. So our result here just has an int ID, and it has a string name. Great. So then we'll go in here, we'll write a for each, and we'll say for each results are in, and we can go to our context, and we'll call execute store query, new method that we added in .NET 4. So execute store query of that type, pass in our SQL query, and now we can write code that processes the result of that arbitrary SQL with strong types. So you could get the IntelliSense there, you'd get compile time checking if we were doing something strange with those guys. And let's run this program. And there is the contents of your sysobjects table, right in the middle of an entity framework program. Now, we didn't show it, but there's also an execute store command where if you wanted to do an arbitrary update statement or something that didn't return results like this, you can do that as well. So super easy path directly to the database from your EF program. Now, how many people in the room are freaking out because you think straight SQL in the code is going to piss somebody off, and your DBA is not going to be happy with that? OK, there's a few hands going up. So you can do a really similar thing with stored proc. So let's take this.
Great.
Let's go use the great tools in Visual Studio for editing T-SQL. And we'll go in and add a stored procedure that does basically the exact same thing that we did here. So exact same thing. Great. Takes no parameters. We'll go in here, and we'll put the same query that we wrote before. Great. So now let's go to our model. And let's inform the entity framework that this stored procedure exists, because it didn't know about it at the time we created this database. So we'll say update model from database. It's going to go out and discover that that stored procedure is now there. We'll click on it, bring it in. And so now all we've done is we've said to the entity framework, look, in our database, this stored procedure exists. We now have to make it callable from our model. So we'll go in and add a function import. And here, we can import it under the same name. And we know this thing returns a structured result. And we want a complex type in our model that corresponds to that. But we don't have one right now. So here, this is a new feature we added. We can call get column information, or press the button. And we sense the result shape of that stored proc. We can create a new complex type that corresponds to that. And we'll call it exact same thing results. And we'll click OK. And let's rebuild our app just to get all the code changes that have occurred compiled in. And now we can get rid of that nasty inline SQL there and change the results, or change what we're calling here, to call the exact same thing method. So our stored proc now shows up as a method directly on our context. And that complex type that we created, we've got a class for that as well, so we don't need that one we hand wrote. And now we can run it, and we'll see the same results, and it happened through a stored proc in the database. I think they like that. All right, so one more thing. So let's look at database functions. So one of the things you wanted is the ability to take link queries and be able to extend what they do by having them invoke functions in the database. So Chris, let's go into the same database tools. We'll add a function. We'll add a scalar valued function. Let's do one that transforms a string. We'll call it let's do an nvarchar there.
You guys with your globalization.
Yeah. And let's make this thing just return the result of upper on our string. And let's save it. Oh, it returns an nvarchar. Good to declare that. Great. And we'll call it myUpper. Now, upper is a function that exists. You could imagine this being any function that you would write that does any crazy database thing. So now that we've got this, let's go back to our code. And let's write a little stub that will tell our link processor what that function looks like. So we'll create a helpers class that just has stubs. So we'll write a public static string, myUpper, that takes a string as an argument. And of course, we're not going to implement it. The purpose of this is just to tell us what the signature of that function is going to be. So this should never be called. And we're going to annotate it with an EDM function attribute. And this is going to be in a namespace that we need to bring in. And we're going to give the namespace of our model, which I believe is model1, and the name of the function in the store, which is myUpper. Great. So now let's go into the code here. And instead of what we have here, let's write, we'll say for each s.
Actually, let's do
Oh, we'll do a query this way, right? So from s in context.speakers, and we'll select some new anonymous type where we'll select the original speaker name, and we'll select the modified s, or helpers.myUpper, and pass in the string name. So through our link query, it looks like we're calling that function. And we want this to actually invoke the function in the database. Because on that stub, we've put that EDM function attribute there, our link processor in the entity framework knows how to do this. So here, we're going to write the results of that query. And we should be good to go.
Right?
Great. So let's run that. Or not. What did we do wrong here?
It didn't work.
Didn't work.
Great. So
we have our
pretend we just
namespace
got out this great uppercase string. It was a beautiful
Trust
thing.
us, it totally works.
Thank you.
Yeah.
Thank you. So,
Yeah.
but
OK, we'll skip over it for now. We'll see what we did wrong. We probably got the namespace wrong there or something. But link is extensible through this mechanism in the entity framework 4. Awesome. So you got to just take our word for it sometimes. All right. So let's, should we switch tracks to a different application?
Yes. This one's now
I think
cursed.
this app that we've evolved over this session is probably past its usefulness. So let's go in and build now a web application. And we're old school guys, so we'll just do a straight web forms application, none of this MVC stuff for us. Of course, everything we're showing you, you can do in an MVC app.
Great.
So we've created a new application. And we'll add a new entity data model. And this time, we'll build it from the database. So let's do.
Whoops. I needed to add
Oh, he added a default page. Great. We started from an empty ASP.NET application, which is a new project template. It comes with none of the junk that you usually get when you do a web application. It's a great way to start from something clean if you want to do that. So we'll create a new model. We'll point to an existing database. And here we'll choose a database that we kind of pre-built here, because we wanted to show something. This is a hugely more complex model than the one that we built on stage. You'll notice, in addition to talks and speakers, it also has rooms, because talks are no good without a room. So we'll bring that in. And you'll see that the entities all get hooked up like this. Now, room and talk, there's a one-to-many relationship between those. And I want you to notice something that showed up in that talk entity that you wouldn't have gotten in EF3.5. There's a room ID field here. So you guys asked for the ability to have foreign keys show up in the model, and we've added that for you. Previously, it would have just been a reference. Now you have the foreign key. So let's show what gets easier with that. So all the people clapping probably know what gets easier, but let's actually show it. So let's build a master detail here. We'll do a drop-down list that runs at the server. We'll give it an ID. And we'll give it an auto postback equals true. And we'll do a grid view. So we're going to just build a page that has a drop-down list of rooms and a grid that will show you the related talks that happen in those rooms. And of course, you would go normally do an object data source and bind that way. We're going to do this the old school way in code. So let's spin up our new context, demo2 entities. And let's see if we're not in a postback. Let's bind up that drop-down list. So we'll set the data source to the context.rooms, and we'll call toList on that. We'll set the data text field to the name property. And we'll set the data value field to the room ID, or ID, just ID. And we'll call it data bind. So that sets up that drop-down list. And now let's pull out the selected value from that list. So we'll get an int room. We'll parse the selected value, selected value from the drop-down list. And we'll bind the grid to the context, or we'll do it this way, from C, or
talk
in context talks, where talk.roomID equals room. Now, notice this was a super simple query to write because I had the foreign keys. Prior to this, I would have had to go do a span query that included the rooms and then navigate through that, which would result in subqueries to my database and so on. Now that I've got the foreign keys, this is super, super simple to do. So there's tons of scenarios like this, especially when you're doing MVC, where you get IDs on the URL. You need to do queries that way. Having the foreign keys in the model is super useful. So when we start up this app, we should get a handy drop-down list here. Room A has one talk in it, and room B has another talk in it. So you can see when we change that, we get our master detail. So super simple example of what foreign keys can give you. So that was ASP.NET. There's also another kind of app that we know that folks build.
They're near and dear to my heart.
Yeah, it's something that Chris has a little bit of experience with. Let's build a WPF app. Now, one of the things you asked for was to have better integration between the entity framework and the different app models in .NET. So we just showed you an example of that with ASP.NET and how foreign keys works better with the way ASP.NET works. Here we're going to show you something we've done with WPF. So we're going to build the same master details here, and we'll look at what you get in the new VS 2010. So we're going to go in and we'll add the entity data model, do the same steps that we did before. We're going to pick that model that has the rooms in it. We'll select all of the tables, bring that into the entity designer, and get going from there. Now, on the design surface, we can go to our toolbox and bring in a list box. Let's put that on the left. And Chris, being WPF guy, is going to make all this stuff
it's going to be beautiful.
Line up and resize correctly and dynamically expand and all that good stuff. Great. And let's set that grid to maybe auto-generate the columns. Great.
Great.
OK, so far, so good. Now let's go over to the Data Sources tab. Now notice, we didn't do anything. We just added an entity data model into this project. And by default, you get a set of data sources associated with that. So we can drag these on. So let's drag rooms onto that list box. And let's drag the related talks from the rooms onto the grid view. And let's F5. And there you have our list. And when you change to selected one, you see the related items over there. Now notice, we got all that stuff just through this simple drag-drop experience. This is an example of where the entity framework is better integrated with the rest of .NET and the tools. The WPF designer now knows about the entity framework. If we look at the code behind file for this guy, you'll see a lot of the code we would have had to write by hand before was done for us, spinning up the context, connecting the queries to the collection view sources, and all that was done for us really simple out of the box. So that's a great way to get started building thick client apps with the entity framework in .NET 4. Great. So let's do one more app, our last app, console application. Now, what we're going to show you here is something that isn't in the box in .NET 4. So part of PDC is you get to hear about future stuff as well. So we're going to show you an example of something that ships in the Microsoft Data Entity CTP, or the Entity Framework Features CTP, which is available for download today and installs on top of .NET 4 Beta 2. And we're going to show you a feature we call code only. So remember before when we built our POCO classes, we typed out our class, speaker, and talk, and so on. So imagine we did all that. We just did it there a little faster than we did before. So same POCO classes with just our properties, and we initialize the collections and so on. And now let's build a program. And notice that there's no EDMX file in this solution at all. We did not add an entity data model. Instead, what we're going to do is use this new thing we call a context builder. And we'll resolve the namespace of that, probably.
Oh,
so
eventually.
We'll create a context builder of our container class. And now we can go in and spin up a context. And we'll create that context using the context builder instead of newing it up. The context builder is a component that we added in this feature CTP that will take those class definitions that you provided and build all the same metadata that we would have gotten out of the EDMX just from those class definitions. So if you don't want to do a model or reverse engineer from a database, you can start just by typing your C# classes. So here we're going to spin up a context. We're going to point it at a database that actually doesn't exist anymore or at all at this point. And we're going to go in and get going here. So let's go in and check if that database exists. We have a new method on the context called database exists. And if it is there, we'll delete it. And we'll create a new one. So of course, this is a great practice to do in production applications. There's no risk of data loss or anything like that here. But so this is going to work great.
This is going to be awesome.
This will be awesome. So let's instantiate a couple of these guys. And see his typing speed just improved like 10,000% there in the last few
This is
minutes.
what the EF gives you, the ability to type
The
that
ability
quickly.
to type at like 1,000x there. Yeah. Great. So we created these talk and speaker objects just like we would have before. We add them to the context, and we'll call save changes. So let's run this. Let's hope it works.
I doubt it will. We did the same thing
No
we did in
faith.
the last talk. We did in the order.
Oh, look at that. We got an exception.
Yes.
What is our exception?
We did the same error we did previously, so it worked out well. We're glad we can repeat ourselves. Primary key violation.
OK, so one of the things you'll notice is because we didn't have a model, we didn't have a way to tell the system that those ID columns are server generated. And we didn't specify them so they would get the default value of 0, which would result in a primary key violation. So we're going to use the Fluent API that we added on the builder to actually go in and tell the system that those are identity properties. And we'll do it on both talk and speaker. And you can use the same API to customize lots of things about the model. You can say, you can apply constraints to things like max length. You can map inheritance hierarchies, complex types. The full richness of the EDM you can express this way. So here he's saying that it has a max length. You can say it's required, all sorts of constraints. So That's probably good enough for now. Great. So if we run the app again, we'll again, of course, drop the database, recreate it, and go. And if we refresh here, I think we need to probably connect to a different database.
What do we call it? Last demo?
Last demo.
Go.
So you'll see in here, just through creating code, we got our speakers and talks, and the data that we added is all in there. So at this point, we could continue working with that just like it was a normal entity framework model, but no EDMX, just pure code. So if you like code, this is a great way to get started. All right? Fantastic. So we're done with our marathon at a sprint pace of demos. And we're going to recap. So this is the list of stuff that we showed you. We're going to spend 20 minutes on each one of these. No. There's a ton of stuff in the Entity Framework 4. What I want you to get out of this is it is ready for prime time. Use it today. It's got all the stuff that you guys asked for after seeing the first version. There's more coming. Code Only is a great preview of what we're doing next. There's only more to come. We're going to continue doing these feature CTPs and improve based on your feedback. Now, if you're looking at this and thinking, oh my god, I've just seen like 17 different ways to get started, here's the thing you got to remember. There's lots of different ways to approach the entity framework, depending on whether you start from a database, you want to build a model from first, or you want to start with classes. This is the way. This is some guidance on how to do that. We're not going to really go through this in detail here. If you attended Chris and Don's talk earlier, they explained this in some more detail. You can watch that online. But really, these are just different ways to get started. And then once you're in there, it's the same entity framework that you're using in all of these scenarios. So calls to action. We would like you to go play with this stuff and give us feedback. .NET 4 Beta 2 is out. Everything you saw us do today, you can do with that, plus the feature CTP. You can get both of those on our new data developer portal on msdn/data. And you can give us a ton of feedback through our blogs. There's the ADO.NET team blog there, which is more about announcements and that sort of thing, and the EF design blog where we post design notes as we build the next round of features. And with that, we'll encourage you to do evals, and we'll open it up for questions.
Any questions? All right.
Questions?
I see a question on the left.
Question over here.
Oh, sorry, the right from the back.
With the lazy loading,
Yes.
Are the properties during serialization and during the save methods touched, so which would cause a background load?
With lazy the question was, with lazy loading on, are the properties touched on save operations?
On the save operations.
On save operations, no, because based on the object context, we know what things have changed or not and whether we need to touch those properties.
Okay.
Like if you've touched them previously, loaded stuff, and we know about related things that have changed, we'll of course persist those, but we don't touch those properties. One of the things that you said there, I think, serialization. Of course, in serialization, everything gets touched. So you probably, in those scenarios, want to turn lazy loading off, explicitly load what you want, and then serialize that way. But for saving, that's not a problem.
But serialization will send it out.
Yeah.
Okay.
Yeah.
All right. On the this side?
Yeah.
Oh, wait. We're getting a. Just a minute. I can't tell their hand signals.
OK.
Is this on? Is that better? OK, there we go.
OK.
I have a couple quick questions.
Yeah.
Is the object creation pluggable? Like when you query, you've got a new up objects. Like if I want to use a DI container or something to create those, can I plug in a different factory?
OK, the question was, is the object creation pluggable?
So when I say context, do you understand what I'm
Yeah,
asking?
so you're saying when you do a query against the context and
You wanna
we
do a factory
materialize
method,
results, is that pluggable? So I don't think it's pluggable in the way you're thinking of, but of course the data classes themselves are completely customizable. So you can, of course, in the constructor there, do whatever you need to.
Right, but if I want to take arguments in my constructor, right?
I don't think that's pluggable. I don't think that's pluggable, at least not in this version.
I would really like it to be in the future.
OK,
Good feedback.
Noted.
We already have the next feature to have.
Yeah.
Great.
On similar vein, I guess, is iObjectSet, does that extend iQueryable?
Yes, so iObjectSet is iQueryable with the add object, delete object methods that you need to basically do the change tracking for inserts.
Okay, so that's a contrast with link to SQL, right? Where entity
Yes.
set doesn't
Yep.
have that. Okay, thank you.
Great. On the other side?
Yeah. Actually, I had a second question from earlier on. Sorry for cutting.
Okay.
Can you import conceptual models into the designer?
Can you import conceptual models into the designer? So you can certainly reverse engineer a conceptual model from a database. If you have an EDMX somewhere else, of course, you can load that.
But I have an EDMX in one project that
Yep.
I want to reference. I want to reference the conceptual objects in one EDMX in another EDMX. You can do it. You can do it with your own code, but
Yeah.
the designer never supported it.
In the designer, I don't
sorry
believe
about
that's
that.
supported.
All right, I'm sorry to interrupt, but we're actually over on time.
Oh, we are? Okay.
We have to take questions right outside the door. We can take questions or we can take them back at the booth. I'm
Great.
sorry about that. I thought we had another
I was
4
looking
minutes.
at that, and yep. Thank you.